right, kiddos, we are getting into lesson 15, conditionals today. Conditionals are fun. So conditionals are also known as Boolean expressions, and this lesson introduces them, and it will allow your program to run differently depending on whether a condition is true or whether it's false. You're going to start by playing a short game in which you respond accordingly to whether a particular condition is met. Then you're going to move into the code studio where you learn how to evaluate Boolean expressions, and they can then be used to structure a particular program of yours. The question of the day that we're going to work on is how can programs react to changes as they are running? So we've only got 8 levels of this one, so pretty short, but conditionals can be a little chewy. So we want to make sure that we're paying attention to how they work so that we can use them in our upcoming game that we're going to create. So let's get started. Level number 1 is a predictor level, and as you know, in predictor levels, they like for you to take a look at the code that's there and try to guess what's going to happen. Before we start to guessing, though, I want to read the Boolean expression definition to you. It says a Boolean expression is an expression that can only evaluate to true or false. So we use these to drive the mechanics of games. Is a key being pressed? True. Therefore, the key may make your character go up or down. Is the key not being pressed? If that's the case, then maybe the character doesn't move. So that's kind of an example of how Boolean expressions can apply. So right here under predictor, you have to read the code below. There's some new symbols in which you haven't been introduced to yet. Take a look and then take a guess as what you think they mean and try to answer the question. So the question says, which statement will be printed in the console by this program? So I'm not going to show all that down there, but take a look at what you think is going to happen. We've got a var sprite 1 and a var sprite 2. Then we have new blocks called console.logs. So the first one says console.log sprite 1 y equals sprite 2y. Pay very close attention to this symbol right here in line 5. 2 equal signs together in programming means equal. 1 equal sign in programming means gets the value. Line 6 says console.log sprite 1x is greater than sprite 2y. And then in line 7, console.log sprite 1x is less than sprite 2y. So you're going to take a look and predict what you think is going to be printed. Remember, Boolean expressions evaluate to true or false. Hint, hint. So let's see what we're going to get. Okay, so down here in our debug console, we see the word true, false, true. So what this is saying is in line 5 is true, that sprite 1y does equal sprite 2y. The next one, line 6, is false. It means that sprite 1x is not greater than sprite 2x. And then the last one, evaluated to true, sprite 1x is less than sprite 2y. Let me see what I have marked down here. So we had guessed true, false, true. All those others, you could have gotten other trues and falses. You would have never gotten letter B, 0, 200, 100. You would have never received that as an answer. You may have gotten an error, but I don't recall ever seeing an error. So maybe you have. I don't know. Let's move on. Let's move on to the fun stuff. Okay, let me hide my answer key. Hurt. Okay, so we have matching comparison operators. So what we've got to do on the left is read the plain English, and on the right, we have to read the computer language, and we have to match them together. So what means what? Well, ladies and gentlemen, if you haven't figured it out yet, you need to know the difference between greater than, less than, and equal to. And if you don't know those answers, you're gonna struggle a little bit. So let's practice. In line 1, first line on the left, it says, is the dog's sprite's rotation less than the cat's sprite's rotation? So the words that mean the most to me in that sentence is dog rotation less than cat rotation. So let's find something over here that sounds like dog rotation less than cat rotation. This one's pretty easy. Why? Well, because there's only one that says rotation. So does this in fact say dog rotation less than cat rotation? Yes, it does. Let's look at the next one. Is the dog sprites X less than the cat sprites X? What words matter to me in here? Dog X less than cat X. So let's find it over here. Dog X less than cat X. So we've got three options here. Which one is less than? We've got dog X, that's greater than cat X. This one is dog X less than cat X. And this one is dog X equal to cat X. So the sentence says less than, so I need this one, the less than. Remember, got to know the difference between less than and greater than. The next sentence, is the dog sprite scale greater than the cat sprite scale? So, words that matter to me. Dog scale greater than cat scale. Which one over here says dog scale greater than cat scale? Well, you've only got one that mentions scale, and it does happen to have a greater than symbol, so that must be it. Next one. Is the dog sprite's X greater than the cat sprite's X? So which one out of the two left is greater than? Greater than. It would be this one. Dog X greater than cat X. And then the last one. Is the dog sprite's X equal to the cat sprite's X? Which words matter? Dog X equal to cat X. Does that say equal to? Yes, it does. Grab it and bring it down. Now, before I hit submit, just so you know, if you ever screw these up, it's not a big deal. It'll just tell you something's wrong and you got to go back and fix it. You can't go past this level until it's right. I'm going to hit submit. Looks like we got it right. And we're moving on to bubble 3. Bubble 3 says this level follows a video that you may have watched in class. If you missed the video, you can watch it in the help and tips tab of this level. So Booleans. The program draws a race car and a finish line. We are going to figure out when the race car crosses the finish line. The sprites have been set up for you. Do this. We need to find out if the race car has crossed the finish line. Add blocks to the text command to print the Boolean to the screen. Add a less than block to the text parameter of the text block. Add a sprite X block to both sides of the less than sign. Make sure to update the sprite.x blocks with the names of the two sprites so that the Boolean is asking, is the X of the race car less than the X of the finish line? Okay, so first thing, let me start over so I do this with you. Sounds like there's a lot of words there, but it's really not too bad. So the first thing I got to do is find my text parameter and find a less than block. So let's take a look. Okay, right here. My comment tag in line 20 says add blocks to the text command to print the Boolean to the screen. So right here in line 21, that's where I'm going to put my less than operator. Bam. Line 21. Next, my directions say add a sprite.x block to both sides of the less than sign. I'm going to go to the sprites drawer in the toolbox, grab a sprite.x, put it in the front, and grab a sprite.x and put it in the back. All of this I'm doing to line 21. Now I have to get my labels correct. So what am I trying to find out? I'm trying to find out, is the X of the race car less than the X of the finish line? Okay, so is the X of the race car, so I'm going to use race car first. Command C for copy. Command V for paste. So is race car X less than finish line X? Command C for copy. Back down here, Command V for paste. So now line 21 says text, race car X less than finish line X, and then it's showing up at 100X and 100Y. We are now going to hit run to see what happens. Here we go. Okay, do you see this blue false right here? So this statement keeps saying that's all false until it is no longer false. Did you notice that it went to true? Let me run it again. Watch this blue word here. Car is moving, statement is false until the car crosses the finish line, and at that point that statement is true. The race car X does become less than the finish line X. That's how Boolean expressions work. Let's move on to bubble 4. All right, bubble 4, we've got if statements. New block here, folks. Boolean expressions allow us to ask questions, but in order to use those questions to change the program's behavior, we need an if statement. Read the code for this race car program. What will the program do when the race car crosses the finish line? Why is the if block inside the draw loop? So we're going to have to put an answer in here. Let's look at the code first. So they are specifically talking about lines 13 and 14. Line 13 says, if race car X is less than finish line X. Line 14 says, text, the orange car is the winner. So it appears that something's going to happen if race car X is in fact less than finish line X. Now, why in the world do we think that this is in our function draw? It has something to do with what the function draw's purpose is. Do we remember what the function draw is used for? If you recall, the function draw is where all the magic happens. All the code inside the function draw is repeated over and over and over again. It's read continuously by the computer. So the reason we put that if statement inside the function draw is so that the computer is constantly checking to see if that statement is true or false. The minute it changes from false to true, the text that is inside the if statement is going to print on the screen. So I'm just going to put, can you guess the answer? The computer will print the text once the statement is true. Okay. Those of you paying attention, the answer is right there. All right, let's hit run and see what's happening. Okay, we got nothing. We got a car. We got a finish line. Once the statement is true, there we go. We got words on the screen. The orange car is the winner. So the words did not show up so long as that statement was false. The minute that that statement was true, the race car X was in fact less than the finish line X, then the computer executed the code that was inside the if statement. Okay, pretty cool stuff. Let's move on to the next one. In Bubble 5, it says this level follows a video that you may have watched in class. If you missed it, you can check it out in the Help and Tips tab. Changing fruit. Now that we know how to use if statements, you can do more than just check the apple has reached a scale of 2. You can turn it into a pear once that actually happens. Do this. Use a conditional if statement in the draw loop to check whether fruit.scale is greater than 2. If it is, change the fruit's animation to pear. So first we're going to add a conditional to our draw loop. Okay, don't forget these comment tags are here to help us as well. It says add a conditional to the draw loop, add code to the conditional that asks if the scale of the fruit is greater than 2, add code inside the conditional to change the fruit to a pear. So first I need my if statement. Go to the control drawer, new drawer, grab the if statement, bring it over. We now need to check if the scale is greater than 2. So I'm going to grab a greater than from the math drawer. Remember, if you forget which one's greater than, just hover over it. It'll tell you. This one's greater than. And what am I checking? I'm checking scale. Go to the sprites drawer, grab a scale. I'm going to put that in the front of my math equation. My label is not Sprite. My label is fruit. There's fruit. Command C, Command V, copy, paste. So if fruit scale greater than, what number did it say? Greater than 2. If fruit scale greater than 2, what do I want to happen? I want the conditional to change the fruit to a pear. How do I establish the picture stored in the variable? Look at my line 2 here. This is the line of code that adds the picture of an apple to the variable labeled fruit. So I'm going to need another one of these. So let me go down here to my if statement. I'm in my sprites drawer. I'm going to grab a set animation, bring it over, put it inside my if statement. Remember, my label is fruit. Make sure you type fruit. And then at the very end, I have 2 options, apple, pear. I'm going to select the pear because that's what I want to happen. So in plain English, line 15 and 16 reads, if fruit scale becomes greater than 2, fruit is going to change to a pear. Let's see if it's accurate. Here we go. Hope you all don't have anxiety watching the apple. Is it going to happen? Oh, there it went. So apple to pear, just like that. Let's move on to bubble 6. All right, bubble 6, we're going to start with letter A. We're going to do A, B, and C. Here we go. A, Boolean expressions. It says the simplest Boolean expressions are questions that the computer can answer as true or false. Another way to say this is that Boolean expressions evaluate to true or false. We're going to modify only the values of the sprite properties in the first 11 lines of code so that each of the Boolean expressions at the bottom evaluates to true. Okay? So let's take a look here. I'm going to look at the first 11 lines of code. For each of the Boolean expressions in lines 16 to 20, we're going to identify the sprite properties that are being compared, and then we're going to change those properties at the top only. We're not going to modify the Boolean expressions. Okay? So what am I talking about? Here's what I'm talking about. Take a look. We got sprite 1, sprite 2, then right here, line 13 says, do not edit the following. I'm serious. So we're looking at these Boolean expressions. So in line 16, it's comparing, and it says, sprite 2x equals sprite 2y. We want that to be true. Let me go check and see if it is. Sprite 2x equal to sprite 2y. Where's sprite 2? Here it is. Is sprite 2x equal to sprite 2y? Currently, it is not. So I'm going to change one of these. I'm just going to change the y to 300. Now, sprite 2x is 300. Sprite 2y is 300. Line 16, comparison number 1 is going to be true. Okay? If you want to know, let's hit run. Do you see it on the screen here? I now have line 1 comparison is true, but the rest are still false. So let's fix these. Line 17, sprite 2 rotation less than 40. Sprite 2 rotation less than 40. That's line 10. Sprite 2 rotation gets 60. Is that less than 40? No, it is not. Pick a number less than 40. It can be 39. It can be 20. It can be 1. As long as it's less than 40. I'm going to hit reset and run. Okay, comparison 2 is now true. Let's look at comparison 3. Comparison 3, line 18 says, sprite 1 scale is equal to sprite 2 scale. Okay, so let's look. Sprite 1 scale, line 6, is 1.5. Sprite 2 scale, line 11, is 0.5. I got to change one. Doesn't matter which one you change as long as they match. So I'm just going to change Sprite 2 to 1.5. I'm going to reset and run. My comparison 3 is now true because both Sprite 1 scale is 1.5 and Sprite 2 scale is 1.5. Again, choose any number you want so long as they match. Comparison 4 says Sprite 1x greater than 150. Sprite 1x greater than 150. Let me go find Sprite 1x. There's Sprite 1x. Right there, Sprite 1x. Is it greater than 150? Nope, it's 100. So let me change it to 151 because it's got to be greater than 150. It didn't say greater than or equal to, which is a thing in programming. It just says greater than. So let me hit run, see if that evaluates to true. Yes, it does. So now line 4 is true. Let's look at the final comparison. Final comparison says Sprite 2y less than 200. Sprite 2y less than 200. So let me go back up here. There's Sprite 2y. Man, didn't we change this before? I feel like we did. But I'm going to fix it for comparison 5. So let's look. Question was, is Sprite 2y less than 200? No, it is not. So let me change it to 199. Now watch what happens. Here we go. Comparison 5 is true, but now comparison 1 is false. So let's look at comparison 1 again. Line 16, it says Sprite 2x equals Sprite 2y. Ooh. So I've got to make line 8, Sprite 2x and Sprite 2y equal. But I also have to have Sprite 2y less than 200. So that's easy. I'm just going to make them both 199. Okay? Make them both 199. Okay, now let's check. Reset, run, bam. Look at that. All of them are now true. As long as you've got true printing on the screen, you are good to go. Okay? All right, I'm going to hit finish. Let's do the dropped soup. Dropped soup is fun. Okay, so we're going to add a conditional if statement in the draw loop to make it look like the soup spills out of the bowl when it turns upside down, like the image to the right. So watch the image to the right. Soup, then empty bowl. Okay, we're going to run the program to see how it works, add a conditional that detects when the bowl is upside down, and set the sprite's animation to empty bowl. One of the things that's not as clear as I wish it was for this level is you actually have two pictures in your animation tab. You've got a stew and you've got a bowl. So basically what we're doing is we're saying once the sprite's rotation is a number, whatever number we determine, then we're going to change the picture tied to the variable. Okay? We've done this before, so don't freak out. We've done this before. So first I start with an if statement. Drag it over. We know that rotation is what's changing. I can see that in line 6. I need to know once the rotation is greater than a certain number. I don't know that number yet, but I do know that it needs to be greater than because rotation is increasing. And how do I know that? Because right here it says +3. It means rotation is getting bigger. Okay? So if sprite rotation, because that's what's changing, if sprite rotation is greater than, I don't know, let's pick a number. Let's say 100. We might change this, okay? So if sprite rotation, if soup rotation, don't forget your label. If soup rotation is greater than 100, then I want the picture to change that's stored in the variable, so I need a set animation. I'm going to drag that over, and the label is soup. If soup rotation is greater than 100, I want soup set animation to become bowl, not stew. Stew at the top. See right there in line 2? So I want it to become bowl. Now let's run it to see if I'm satisfied with 100. I might need to change that number. What do you think? Watch it. Seems like it's a little too soon. Let me change 100 to 125. Let's see what that looks like. That's better. What do you think? Let's watch it again. Seems to comparing it. It's pretty close. So I'd say something around 125. If you got a little less, a little more, not a big deal. It's just got to look like the soup's falling out. Okay? So what did we do here? We added lines 10 and 11. We added an if statement. We created a conditional that said if soup rotation greater than 125, then soup set animation becomes bowl. Okay? Pause if you need. Hit finish when you're ready. All right, last one. Alien celebration. This is not the last, but the last one of lesson 6. We've got alien celebration. Use a conditional to make the alien dance when the spaceship reaches the top of the screen. Run the code to see what happens. Add a conditional that detects when the spaceship is in the sky. Set the sprite's animation to be a dancing alien. Okay, so let's run it, see what's going on. Spaceship leaves, alien does nothing. So we want the alien to dance. Okay, here we go. We're going to go control if statement. Okay, we know the spaceship is what's changing. We know the spaceship is going up into the sky, which means the y value is decreasing. I also know that because there's a subtraction problem right there. Okay, so if spaceship y, I'm going to choose less than because spaceship y is decreasing as it goes up. So if spaceship y, S-P-A-C-E, ship, if spaceship y is less than, here's where it's kind of up to you. Pick a number. What's considered the sky? If I put my cursor here in the middle, I kind of looks like y is 140. So I'm just going to start with 140 and see how I like it. Okay. So if spaceship y is less than 140, what do I want to happen? I want the alien's animation to be a dancing alien. Do I already have a dancing alien? Yes, I do. Okay. So this is a simple matter of grabbing another set animation, throwing it in my if statement. Now be very careful with this. I don't want the spaceship to change. I want the alien to change. So I'm going to use the label alien. Okay. So if spaceship Y is less than 140, alien set animation is going to become alien dancing. Okay, so let's see if we like it. Here we go. Yeah, pretty good. Let me run it again, a little bigger so you can see it. Huh? I like 140. I'm happy. I think I'm going to leave it. If you want a different number, then by all means choose a different number. Hit pause if you need to. All right, we're going to go on to finish, and we're doing your assessment level. So in this one, we have a magic dinosaur. It says use an if statement to make the dinosaur turn into a pterodactyl when it reaches the sky. Do this. Run the code to see how it works. Add a conditional that detects when the dinosaur is in the sky. Set the sprite's animation to be a pterodactyl when it reaches the sky. Okay, so we got one dinosaur, and that dinosaur currently is a T-Rex, Tyrannosaurus. If I hit run, we got a Tyrannosaurus Rex in the sky, which looks kind of weird. So we're going to fix that. Okay. Looks like we've got our if statement. Do we have our if statement or did I do that? No, we did not. Let me do that with you. I don't want to confuse you. Okay. So I'm going to go to the control drawer. I'm going to grab an if statement. I'm going to put it below my comment tags. I've got to check to see if the dinosaur's Y is in the sky. So this is kind of like the spaceship and the alien again, okay? So if the Y is in, or is, if the dinosaur is going up in the air, then the y is decreasing. So therefore, I know I need a less than operator. See how, like, I'm thinking it out loud so you can hear my thought process. So if dinosaur y, that's what's changing. How do I know that? Because that's what's right there in the function draw. So if dinosaur y becomes less than, pick a number. I used 140 last time. I'm going to use 140 this time. Maybe I'll change it. Maybe I won't. Who knows? Let's find out. So if dinosaur y is less than 140, I want the dinosaur to change from a Tyrannosaurus to a pterodactyl. So I know in order to change the picture stored in a variable, I need a set animation block. So I'm going to grab set animation. I'm going to Command C the word dinosaur, Command V to paste. And at the end, I have to choose the pterodactyl, which starts with a P. Okay, the P is silent. Pterodactyl. So I'm going to choose the pterodactyl picture. So now my if statement says if dinosaur y less than 140, dinosaur set animation is pterodactyl. Let's see how it looks. Bam. Turned into a pterodactyl. That's it. Okay, that's it. Hit pause if you need to, or hit finish if you're ready. Okay, so down here you've got 6 different options for your challenges. I would like for you to try these challenges on your own. I would do at least 3 if I were you. This visible is a really cool block. You definitely want that. Some of the rest of these look new. Never ending scene, that looks pretty cool too. If you do need any help with these, come see me in class. Otherwise, have fun with lesson 15.